Okay. So see first. Hello. Yes. So as you are using LSTM, so LSTM works on RNN, top of RNN. Right. So RNN has architecture like this. So X is the input. Let's say hi or hello, one word. Okay. So if it is hi, what should be the output? How the response should be? Maybe hi or bye or something. So that uses one activation function. And that is repeated, recurrent neural network. That is do the back propagation and again do from forward or again do is recurrent. So reoccurring. So this is RNN. When one information is there, it pass it and get output. And based on that output, it learns the next output. What should be? So like hi means hello, or A is a neural network which gain information from the previous step. So gain information means activation function. So this network is RNN, but that is not sufficient because at this moment, when you have something, say, how are you? So if you have to say I am fine, so it may relate you before that are is there, before that how is there, how are you? So at this point, it requires you to understand the information of this also. But here only it understands the previous information. Based on that, it can help the next output. This is input. It knows that previous output was there, so it can work on this output. So that is not sufficient. So the long short-term LSTM model works where if you see, these are the many things works in between. This is input and this is output. And not simply activation function, but there are many things. So what the many things do? Sigmoid and 10H. 10H means, so if you see, GANISHING vanishing gradient, vanishing gradient. See, sigmoid stops learning. It only learns from -1 to +1. Once again. This sigmoid helps in what? There are two use 10H and sigmoid. Sigmoid is used to understand based on the information which one information has to be carried forward. Sigmoid works on 0 and 1, right? 0 and 1. So it is a replacement of gate. The gate is like open or close get. So it will allow some information to be passed. So this is input, this is previous output, h of t minus 1. So when it passed through it, if say based on high, what happened that if I say hi, you may say hello, how are you, right? If I say hi, you can respond with hi, or you can respond with hello, how are you? So that means one to many answers can be there. Hello?
Sir, can I repeat the point again? Sir, can I repeat the point?
Okay, I think I'm okay. Yeah. So you are using this one WhatsApp audio, right?
Yeah, sir, okay.
Hello. Can you hear this one? The video from my this. Can you hear the video now? Hello.
Hello.
Yeah. Hello. Now can you hear me?
Hi.
Okay. What I'm saying, this is the input. That is the previous output. Means hello. If I say hello, you said hi. So this is hi, and this is R. Let's say hello. How? Let's say I said hello. How are you? So hello. You said hi. How? And between how, what should be the next information? So it takes the previous. You said hi.
Okay.
So then this information should be passed or not to pass. Or let's say I said hi, you said hello, how are you?
Okay.
So hello, how are you? In that, which one should be passed, which one should not be passed, based on the context of the word. So that is sigmoid is used. So it will allow some words to pass, some will not pass.
1 minute, sir.
Like this one. See, LSTM is a special architecture enables to forget the unnecessary information. The sigmoid takes input xt and h of t minus 1. Xt and h of t minus 1. H of t minus 1 is the output of previous, and xt is the input. And decides which part from the old output should be removed by outputting to 0. Sigmoid may take 0 and 1, so it put to 0, which is not required. Example, he has a female friend Maria. The gender of David can be forget because the subject changed to Maria. Like if something context, some David word is there, so it can be removed because talking in a female context.
Okay.
So the gate is called forgot gate, FT.
What you're saying is here we're thinking about the previous, but whenever it's the main person, it will automatically remove the main person.
Yeah, it will automatically remove the unnecessary information because you can have multiple words from there in previous information cell nodes, and only few words has to be taken. So just assume it like you have few words, and in that you understand the algorithm understand which one is the more preferred, and when valid context, which are valid context, which are invalid context. So invalid it will drop out using sigmoid.
Okay.
And the output is getting by ft into c of t minus 1. So ft and c of t minus 1 is what? Here if you see, memory from last LSTM unit. C of t minus 1, I was talking about the memory where the last information was saved. And h of t is the output of last LSTM unit. This is the output is a value and this is the memory. So we take the memory actually, directly we take the memory rather than writing in a new memory. So ct minus 1 into ft. This is the forget gate. F of t is a forget gate.
Okay.
So next step is to decide and store information from the new input xt in the shell state. So we got some new information xt here. So this x will have, so here it will pass the information to here xt. So then, so out of this new information, which should be passed to form the current output ht. So you may get multiple information which are valid.
Okay.
So out of that, which one you are going to get into your output. The sigma layer decides which of the new information should be updated or ignored. Right? And 10H creates a vector of all possible values from the new input.
Okay.
So here if you see, one might be new input is x, this one another is x. So then out of this, which one will be passing? We may want 1 or we may want 2. If I say hi, you may respond with hi, you can respond it, hello, I'm fine, or how are you, right? So there is multiple information. So these two things works together. The new memory is added to the old memory to give the CT. So CT is this one.
Okay.
CT is, at this point you can see this one. The new output, wherever you are getting X, will be multiplied by the old memory you need to get the new one, XT, CT.
Right. The output is multiplied by the previous number.
Yes. These two, one is XT. The 10 is there creates a vector of all possible values from the new output. Values of all possible vector of all possible input. So in the all possible input, whatever is there, X information are multiplied to update new cell. So this new memory is added to old memory and gives CT. So this is, so one is this output and multiply it by the XT information, all the new information.
Okay.
So then we get the new next information what need to be passed.
Like
So
we are going to multiply the output of the f of t to t minus the output that is multiplied again to x of t.
yes.
Okay. Then again that value is again added to the t of t.
Yeah, this will be your output of HT. This one.
Okay. H t but the like h of t nothing but the multiplication of the previous number with the current number, and that value again is added to the x of t.
Yes.
Okay. After adding that again with the x of t, again we are going to add again h of t minus 1, sir.
Yeah. So the new memory is added to old memory CT give CT. So we get a new. So one new memory is we have created, which having a vector of all possible input, and this will be multiplied with C of t minus 1 to get your CT.
Which two are multiplied? Like f of t is of t minus 1 is multiplied. Then which two are again multiplied?
So here if you see, in our example, the input is this gate is a forget. The output of this gate is output of this gate. So h of t minus 1. So here we apply sigmoid, right? So this one talking at the first step. Xt is equal to, so f of t into c of t minus 1.
Okay, x is equal to.
Here. So then, and then the next thing you will get descendants of information of the new input xt in the current state. The new memory is added to CFT will give CT. So new memory we have created with all the valid information. So this X. So this the new memory. This the X is there, right? Hello. First we are talking about this one to get the only the good information. Then we are talking about applying sigmoid and 10H together to get the all the valid information.
Okay.
This will only pass the valid information, and this will give you the list of valid information. This will be saved in here plus node, right? So plus is the adding information. So if you see, we have applied 10H. 10H is used why why it is required, because sigmoid has only range of 0 and 1, and we lost the information. And 10H has a higher range, -1 to +1 for the output. So if you remember, so that's why we use 10H to, so that while we do optimization, it does not vanishes, that we cannot progress. If it vanishes, then we cannot progress. So there is a problem called vanishing gradient. So here it is might be having 1 second. So might be having down. So I'll tell you. So that was 10H is used to overcome the vanishing gradient. We need a function whose second derivative can sustain a long range before going to 0. And sigmoid is used to forget the information. To get the optimization, we use 10H. The activation function we use actually 10H. And sigmoid is not used in the activation function. The learning graph, because we require different information, and it can already, by putting 0, it can be vanished. So finally we decide to go for the output. The sigmoid layer decides which part of the cell states we are going for the output. Then we put the cell state through 10 is generating all the possible values. So first we get the filtering out the good values. Then all the good values will pass through the 10 is. Okay. Let's say how are you apps? Say fine, good, doing good, like that. Some words are there. So that will be passed to sigmoid, and some will be ignored. So all the past values will be go through the 10H learning rate. 10H is a activation function, a graph, right? So which is a range of -1 to 1. So to optimize that and get into output. So that's why in this diagram it works like this. So sigmoid is working for getting the correct information, and 10H is used on all the valid information to get the output. CT where we are adding all this valid information in the memory.
The confusion actually, I will explain.
Yeah, tell me.
1 minute. Can you go up the diagram?
Pardon?
Web diagram, can you put the architecture?
So I'm not able to listen. What are you saying?
Can you go to architecture, LSTM architecture, the diagram? Yes. Here, first we are, the first step we are multiplying x of t with h of t minus 1.
No, no. Not multiplying.
Okay, so we are taking ht and h of t minus 1 as input layers.
Yeah, is a previous output.
Yeah, this is the previous output and ht. Both are taken as inputs for the sigmoid function.
Yeah, and to get the which information should be passed. Which information? Yeah, which information should be passed from previous nodes to this one. Right.
Which one, sir?
See, if I say hello, how are you? And previously, let's say you are saying I am fine.
Okay.
So then next thing question you ask, are you what's up? You said what's up. So then it will take the previous information which may be related to these questions, and then it will filter out which are the word from previous steps it should take.
Okay.
And save in that nodes.
Okay, external save. Okay. After saving from this node,
then this the valid nodes which are going. So every nodes require a activation function, that is 10h is passed. So
okay.
yeah, so that means, so let's say you collected few words from the previous step, which is good to pass through it, and which are save in this memory unit.
0 t minus 1. Okay.
So this will go through every word will go through the 10h activation function, and to decide which one should be actual the output. So there may come one or multiple output. So it's not necessary that one input should have one output. So one can have multiple output, or one can have one output also. One to many, many to one also.
Then what is the use of sigmoid function? The tanh is the deciding that what's the use of sigmoid function?
Which one? This one?
Sigmoid, yeah.
This one or this one?
Both, sir. In first case you are saying like the
sigmoid is removing the unnecessary one. Previous all the information cannot be filled up in the next, right?
Okay.
Hello, how are you? May result in good, doing good. I am doing good may not required. I am will be ignored.
Okay. Like unnecessary information is removed by the sigmoid function. The tanh function will decide which should go into the output layer.
Output layer, correct.
Okay, that's the function of the tanh.
Yes, yes. It is respective to this one.
That's what I have noted. Like you're saying, like again, sigmoid function application, and again this one. Then what is the use of software function? Can you go to the LSTM network? No, so down. Yeah, here embedding layer, software layer. No, absolutely. Can you go? Yeah, here. Okay. Like, can you explain me what is the embedding layer, LSTM units, and software?
So embedding layer will have, embedding layer means which are the word of the input word. So let's say you have a text of 1000 keywords. So you will use a memory of 2500 words, which will have a vector, creating a vector. Embedding layer means creating a vector of all the possible input.
Can you give me an example?
See, this is a sentiment analysis problem is there, and where they took many different keywords. So they use LSTM output is 200 embedded dimension 120. So x input of 1 input length. So you first created a vector. So here okay, here it is there. Look at this one. It's RNN again. Hello.
Yes, sir. Yes, sir.
When you create a network, so add in that we took the input shape. Input shape is the shape of the column. Shape of the data, number of columns are there.
Okay.
And this is the embedding layer. So this many memory space is required to carry the information. Okay. Then we can use dropout randomly 20-30%. So next layer also we are using. This is the same to pass the information. And then in the last layer we use the shape of y. That is the same thing. So here in the implementation side, you don't need that architecture. So the thing is, if I say hello, how are you as an input, now the architecture, it will go to the architecture and how much output it can produce. The limit you are creating with the embedding layer, embedding vector. So wherever there is a information is there, filled with 1, it's not there, it will be filled with 0.
Okay.
Understood? So
Okay.
I can ask you one question, where is California? The answer can be like a one paragraph, big paragraph, right? Or it can be a one line. So to decide the embedding layer, this much. Okay, so this is used to carry from one input, what should be the output? That is the size of that. So now you can have, so it will work through the whole data set, whole training data, and so every time we are saying this one and ultimately this output set.
Like LSTM will decide how much output should be taken.
Right, that has to be defined. Otherwise, it also requires a memory, right? So, how much information, how much memory cell unit will have. So, you can use Keras embedding layer. It requires the input data to be integer and so that word is represented by unique integer. So we are going to create a text into a vector, binary vector, right? So that is we are talking about the embedding layer. So input dimension, output dimension, and the length. So input dimension, so we have used, I think here I have used not Keras, I think. One second. Okay, Keras only used. So the first hidden layer, that is the first hidden layer is first output, this one. So this is the embedding layer, okay. So the input is the right side, the output is the embedding, okay. This is the size of the vector in which the words will be embedded. Understood?
Like input dimension, expect what would make input dimension.
The vector are like pandas data frame, you understand the number of columns.
Number of columns is input dimension.
You just go and check out the bag of words or word to vector. Bag of words or word to vectors. Put a simple things, and I think covered. So if you see this one, look at this one. See, so this you see.
Yes, yes.
Can you see this one matrix?
0.01.1, yeah.
All 0 and 1. So this is a matrix formed with only this word. So how many rows are there? How many rows? 1, 2, 3, 4, 5, right?
Yes.
So it has. So this has many words. This many words are there. So 1, 2, 3, 4, 5, 6, 7, 8. 8 different words are there in this. And there are 5 rows. So 1, 2, 3, 4, 5, 6, 7, sorry, 9 is there. So 1, 2, 3, 4, 5, 6, 7, 8. So the number of words. So it creates a column for the number of words, and it creates a number of rows as per you send the data.
1 minute. Can I go to the number of rows?
Here you see how it is formed. Work is 1, right?
Let's say work well done, good, great, efforts, nice, excellent, etc.
So the words will be taken in the, 1 0 extra is taken, right? So the number of words are taken here. Then whale is once. So whale is once. So whale is occurred in which one? Index. See the index. Number 1. No. Count. What is the index? Third one. So work is occurring in the second row and this one, right? So 2 times it is occurring. So check on the word work. So 2 times occurring, and the positions will be where is the work. So look at the whale. Whale is the first keyword, and whale is the index at 1. There's a count, right? So documents count, word index. So third print is which one? I need to again run it. And the fourth one is okay, this one. Whale is at the second index, right? Whale is at the second index, so you can put 0, 1, 2. This one, second index is whale. Done in the 3 index, so done is this one. Good in the 4th index, but good occurred in second document. So it will come here. Like this. So great work, great in the 5th, but great should be in the 3rd document. That's why it is here. So this way you can create a vector to matrix, word to matrix using different things, different algorithms. So this is also called the embedding layer in LSTM. So the LSTM embedding layer can be created using word to vector or count vector is a different method. So now just we have seen is a bag of words. I have already shared this code I think with you. Otherwise I will send you. I think I didn't send it because you didn't attend the class. No? So I will send it this code. So hello.
Share me all the documents.
Okay, so
Share me all the documents.
yeah, I will share that. So okay, this is not required. So that was the things, and the code is like you understand this one. Input shape is required. This is the embedding layer, and this is the middle layer again one, and then we use softmax activation function. Now your question was back to why we use softmax is the overall activation function, and in every word, what is be the every word what should be the reply. So every question has every word, every particular word has what should be the reply in that. In that architecture, the 10h is one part as activation function. 10h is a layer. You can say it as a layer, not activation function. This is the overall activation function.
Okay, so softmax function we have a 10 states.
Pardon?
Instead of softmax function, we have a 10 states.
No, no. Activation function you can use on top of it. See, softmax is the overall activation function. There is one activation function required for the whole network, and the 10h is working on individual units, LSTM units. It is working on these units.
Okay, inside the LSTM we have the 10h activation function.
Yeah.
And where is sigmoid?
Here, inside units, individual units. So unit may be many units, right?
Then I did not understand the overall program. So what's the overall program concept? Like overall program, whatever you know, what's the overall program concept? Like I'm understanding, but
First thing is you have to create a vector from the input. So where we will decide on the number of words may be required, the maximum words. Yeah, you can decide that may increase also. So that you can do some trial and error. Then you can put the input shape, the number of columns. So that you can take also the length of first row. Length of first row if you take, then you will get the input shape also. Right? Length of first row of what? The matrix you created by right, the matrix you will be creating, you are getting a text, you cannot create directly a function, right? So here is a tokenizer is there, right? Did you see this one? Fit on text, see, this is the data. This is the complete raw text. So is a tokenizer. So tokenizer of text to sequence. So you created X. So then we require a pad sequence. Padding sequence means some words may be small, some words may be big, right? The answers may be small also or big may also it come. So when it comes a small, so it will fill up all the empty using 0. All the memory units should be filled up. So this pad sequence will help up in that. So you use pad sequence to fill up empty cells into 0. And here, what is the question is, raw text we converted into one matrix. So if you put a length of x of 0, you will get that what is your input dimension required. See, x of shape of 1. So this is your length. This is your input, the column length. And this is your embedding layers. And this is the middle layer, you can put anything. So you put a middle some 200. And the last one you already understood. So what is the problem? It's a sentiment, positive sentiment or negative sentiment. So it puts 2 only. This is a huh?
What is the meaning of middle layer? What is the middle layer?
Middle layer is the deep neural network middle layer.
Like it's a multi-layer concept.
Multi-layer deep neural network. When we say first layer is their input, then will be some output. Indian middle layer should be there, no?
Okay, like this we can keep any number of outputs.
Many number.
Like,
so this is the first layer. So the embedding layer.
So if I want to create two middle layers, then what should I take? This example, if I want to take two middle layers,
Repeat this one. I put it. Repeat this one.
Can you show it?
I already highlighted it. See now.
Okay. Like I need to add model not add LSTM. Like I need to add like this code, like.
Yes. Only this one. This is you can vary. You don't need to put the same only. You just can keep it something around that only. Okay.
Then how to identify the variable?
No. You can hard code also. Here we are hard coding, right? Hello. Yeah, starting input is this one. Input is that, and this is the embedding layer. So it will be your first middle layer's input. So this is the output of this one. Input has the output of this one. So this many cells we are expecting to contain the middle layer information. And then this is the next layer.
Yes, sir.
Hello.
The middle layer, the size of the middle layer is 2 nanosecond. Size of the middle layer is 2 nanosecond.
Yes, size of the input, yeah, size of the middle layer is 200.
What I'm saying is, suppose if I want to have another middle layer of size 50, then is it possible to take another variable, or what should I do?
And just copy this one down next to that and just put 250 out of this one. Not clear? Hello?
Yes, sir. Now you can see here. Like,
See. See here I am doing, see.
Yes, sir. Here I added model node, add LSTM. So if I want to have another layer, then I take model node, add LSTM.
Yes, yes. Again, you put some dropout. Okay. Okay.
Again, I need to copy it, and again, I need to put the add dropout again.
Yeah.
Again, I want to take care of that.
Right. So then, yeah. So image classification, you are going to use CNN, not RNN.
Okay, but the concept is
Yeah, little bit different on that. So I'll send you one video with something. I'll tell you one day. Yeah. So
basically RNN is for test.
no, see, don't mix up the topic. Let's don't discuss about the CNN only, okay? Because this is only a first topic now. Another day we'll discuss, okay? So that is little bit differently work. So don't mix up that. So see, the loss is categorical cross entropy because here the problem is more than two categories. But the example I am showing here is having again categorical cross entropy. So why it is? So loss you can put binary cross entropy also because number of output is 2. So sorry, it's a 3. Positive sentiment, negative sentiment, and neutral, right? So that's why it is categorical cross entropy. It's not binary. So otherwise there is a binary cross entropy here. So optimizer is always Adam in all the networks, CNN, RNN both. Matrix you can put accuracy. That's all. Okay.
They're like what may process.
Pardon?
What do you mean by process sentiment, negative sentiment, and
No. For this problem, so this problem is like this. See, this is the text, and this is the negative sentiment. This is positive sentiment. Okay, this is the target of this data, and this is data. This is the target. So this is the stars. If it is more than something 5, then it's taken as a or 4 positive, otherwise negative. So now execute. You already know this one. How to split the data, train, test, and then yeah, you just follow this one. Rest are no need of concept to get the accuracy. So this is sentiment analysis. You can use GitHub also. His code is there, so you can use it and understand it. Okay. So yeah. Okay, I'm going to stop the video first thing. I will send you